In this problem, we have two cars. We have car A and car B. Car A is moving left towards an intersection at 20 meters per second, and car B is moving up towards the intersection at 10 meters per second. And we want to figure out the velocity, the relative velocity of B with respect to A, and the relative velocity of A with respect to B. Now, the relative velocity, what that actually means physically, is the velocity of B, if I'm with respect to A, is if I'm at car A, what does the velocity of car B look like to me? And if the velocity of A with respect to B, if I'm standing at car B, what does the velocity of car A look like to me? So that's what relative velocities are. Now, let's take the velocity of B with respect to A and rewrite this in a different way. We can rewrite this as the velocity of B minus the velocity of A. And it's important to take into account which velocity is on top of the bar and which is at the bottom of the bar. So the velocity of B is going to come first, and then you're going to subtract the velocity of A. So let's figure out what these velocities are. Let's say that going to the right is our positive x direction, going upwards is our positive y direction. So that means the velocity of B, this right here, is going up. It's only going in the upward direction, so it's going to be 10 meters per second in the j direction. And our velocity of A is going to be going against our positive x direction, so it's going to be minus 20 I, because it's in the x direction, meters per second. Okay, so let's put that into this equation. We're going to have 10j minus a minus 20I, and this is meters per second. This will simplify, the two negative signs will come together, so we'll have 10j plus 20I meters per second. And this is if you wanted to express it in Cartesian forms. If you wanted to express the magnitude, we're just going to have to take the sum of the squares, the square root of the sum of the squares. So this is going to be this 10 squared plus 20 squared, so that's going to be a square root of 500, and this is going to be approximately 22.4 meters per second. And now we just need to figure out the direction. So with the direction, we're going to take our I term and we're going to draw that I term. So this will be 20. Then from the end of this vector, we're going to draw our j term. So this is going to be 10. And what's left is, this is going to be the resultant, and this is the angle that we're looking for. So our theta right here is going to be equal to the inverse tangent of opposite, so 10, over adjacent, which is 20. And this angle is going to be 26.5 degrees. And that's the relative velocity. So the relative velocity can either be expressed this way, or it can be expressed as 22.4 meters per second at an angle of 26.5 degrees. Now, let's look at the other relative velocity. So our relative velocity of A with respect to B. Our relative velocity of A with respect to B is going to be our velocity of A minus the velocity of B. So this is going to be equal to minus 20I minus 10j. And again, if we take the magnitude, so this is expressed as a vector form, and if we take our magnitude, it's going to be the square root of the sum of the squares, so minus 20 squared plus or minus 10 squared. This is again going to be 500, so our magnitude is going to be the same. It's going to be 22.4 meters per second. And if we look at the angle now, the angle, if we start with our I term, we're going to go this way. So this is going to be minus, this is going to be 20. The minus is the direction of the arrow. So this is going to be 20. And then we can go down 10. Again, the negative is taken care of with the direction the arrow is pointing. And we're going to get this angle, which again is going to be the inverse tangent of 10 over 20. And is going to be 26.5 degrees. And you notice right here that the two relative velocities are just equal and opposite. So the relative velocity of A with respect to B is equal to the negative, the opposite of B, the velocity of B with respect to A.